Have you ever wondered why the sky is blue? Or, more to the point, why anything has a color in the first place? Your father's voice might have been deep and your mother's voice not so deep. Whether it's colors or the notes on a piano, these things are all explained by frequency. Frequency is a property of a wave. We are surrounded by waves every day. Light is an electromagnetic wave, and the sound of the fan in your computer is a sound wave. A wave is a vibration that carries energy with it. The frequency of a wave is the number of waves that pass by each second and is measured in hertz. For example, a sound wave might have a frequency of 450 hertz. Light is an electromagnetic wave. It is a vibration in electric and magnetic fields. Because of this, it can travel through the vacuum of space. And thank goodness for that. If that wasn't the case, we would get no heat from the sun, and life on Earth would be impossible. There are more wavelengths than we see with human eyes. A full continuous spectrum would include radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. The diagram on your screen shows the full electromagnetic spectrum and everything it contains. Frequency tells you the color of light. High-frequency light waves are at the blue end of the spectrum, and low-frequency light waves are at the red end of the spectrum. Our eyes detect the frequency of the light, and our brains interpret it as color. Some philosophers have thought that perhaps color itself only exists in our brains. Unfortunately, we have no way of knowing for sure. Sound waves are wave vibrations in the air. When you slap your hand on the desk, it causes the desk to vibrate, which causes the air to vibrate. The air particles hit each other until they reach your ear, making your eardrum vibrate. Your eardrum then sends a signal to your brain. It's your brain that interprets these vibrations. Frequency tells you the pitch of a sound. High-frequency sound is high-pitched, and low-frequency sound is low-pitched. Again, one might ask the question of whether pitch is just the way our brain interprets the waves, or if it's a real thing. Every musical note you could play on the piano is a different frequency. In fact, if you've ever used a tuning fork, you might notice that the frequency of the note in hertz is stamped on it for reference. Our ears can hear frequencies between 20 hertz and 20,000 hertz. When considering light or electromagnetic waves, the red side of the electromagnetic spectrum is low-energy light, and the blue side of the spectrum is high-energy light. Or you could think about the rainbow. The closer you are to the red end of the rainbow, the lower the energy. There is an equation that gives you an exact amount of energy contained in light. As shown here. E equals h times F, where h equals 6.63 times 10 to the negative 34 power. In this equation, E is the energy of the light in joules, h is Planck's constant, just a number, and F is the frequency of the light in hertz. So if you know the color or frequency of the light, you can use this to calculate how much energy is held within it. Waves are vibrations that carry energy. Frequency is a property of those waves and represents the number of vibrations per second that is measured in hertz. Electromagnetic waves, like visible light, radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays, are wave vibrations in electric and magnetic fields. Our eyes interpret high-frequency light as blue in color and low-frequency light as red in color. Sound waves, on the other hand, are wave vibrations in the air. Our brain interprets high-frequency sounds as high-pitched and low-frequency sound as low-pitched. High-frequency light is also high energy, and low-frequency light is low energy. It is an unanswered question whether color and pitch are actual things or just the way our brain interprets light waves and sound waves.